People have been arguing for centuries that 0.9 recurring can't equal 1. This might be because we can produce a pretty good argument against any proof that 0.9 recurring equals 1. And we will examine one of those arguments now. Here we have what's called the intuitive explanation, in which the partial sums are placed on the number line one by one, and we consider what distance remains to the point corresponding to the value 1. Generalising, the distance from the nth term to the point 1 will be 1 over 10 to the power n. So if 0.9 recurring was less than 1, we should be able to find a point that is between 1 over 10 to the power n and the point 1 for all possible values of n. And since no such point exists, the mathematicians conclude that it must equal 1. In other words, they're saying that 0.9 recurring must equal 1 because if you give me any point before 1, then I can find an nth sum that is closer to 1 than your point. But here we can use a cat and mouse argument, in which we can easily switch the roles of cat and mouse around by saying, you give me any nth sum and I can give you a point that's closer to 1 than your nth sum. And since this will work for all possible nth sums, points must exist between 0.9 recurring and 1. So these are two equal and opposite arguments. One implies there can't be any points between them, and the other implies there must be points between them. You might think this shows that 0.9 recurring cannot be any fixed value, and if it can't be a constant value, then possibly the most obvious conclusion is that it must be process related. But they, the mathematicians, want to justify their preconceived notion of so-called real numbers, in which a real number has a fixed place on the so-called number line. So they choose to only accept arguments that fit with what they want to be true. Here, they want the first argument to be valid and the second argument to be invalid. It doesn't matter a jot that these are exactly the same argument, just switched around. It doesn't matter to them that they're adopting an inconsistent approach to logical reasoning. The only thing that matters is that they can claim that their concept of real numbers is consistent. And if it can be made consistent by rejecting the second argument, then so be it. To a disbeliever, like me, this can't be a valid approach, because any ridiculous notion can be called consistent if we are allowed to reject any argument that shows it to be inconsistent. If we're going to be consistent in our approach to logical reasoning, then we must deduce that 0.9 recurring cannot be a constant. But the supporters of real numbers just won't let go of the idea that it is a constant because they've defined it to be a constant. Yes, it leads to contradiction when we assume it is less than 1, but it also leads to contradiction when we assume it equals 1. It's the same kind of logical argument except turned around. But they don't care about the second contradiction. They don't want to talk about it. They won't even acknowledge that the second contradiction exists, because if they did, then they'd have to acknowledge that there's a problem with real numbers. The ignored contradiction is just one of the problems with the mainstream's intuitive explanation. Another problem is that it involves infinitely small points on an infinitely divisible, infinitely thin number line that goes from -infinity to +infinity. We can imagine a thick line, but when we try to imagine an infinitely thin line, it completely disappears. Nobody can truly imagine infinitely small points and infinitely thin lines. we can only imagine solid lines and solid dots and pretend that these represent infinitely thin lines and infinitely small dots. And so the belief that it is valid to theorise about such things has to be based on pure faith. And for those of us without this faith, that we can imagine infinitely big things and infinitely small things, it is invalid and absurd to think that we can conceive of and theorise about such objects. And a third major problem is the problem of the last term. Given that all the points in the sequence 0.9, 0.99 and so on are supposedly static points on the number line, then how can there not be a last point? If we approach the number line from the right, then which of these static points will we encounter first? Or, if we think of these points in an ordered infinite set, and we add a number that's bigger than 1 in this set, what number will immediately precede it? We can't just avoid the issue by saying the least upper bound is 1, because 1 is not in the set. Or if we approach 1 from the left, then how can we have passed an infinite amount of these points when we reach the point 1? And how can we not have passed a last point? We've already seen that we can't construct a length of the square root of 2, because we can't have an irrational amount of pixels on a screen. But do irrational values actually exist? Do values like the square root of 2 really exist on a ruler? If we move our finger along a ruler, then have we really just travelled past all the points? 1, 1.4 and all the other points in the base 10 representation of the square root of 2? Surely we can't suddenly change from having passed a finite amount of these points to having passed an infinite amount of these points, can we? And if we can't transition easily from finite amount to infinite amount, then we've got a clear absurdity here. And the only way that we can avoid this absurdity is to conclude that irrational lengths can't exist in the real world, and that space itself must consist of a finite amount of smallest parts. Finally, thank you for taking the time to watch, and I hope you enjoy my other videos.